Alright, hello guys. So in this video we'll be learning about convolutional neural network और ये एक deep learning model है which works on more than two-dimensional data. तो अगर single dimensional data है so it does not make sense to use CNN. But if you have multi-dimensional data, for example images or audio or 3D images or any kind of data which is represented in 2D or more, then CNN makes sense. What it does, it learns the feature of the image instead of learning from single data point. अब इस लाइन का मतलब क्या है? I'll show you through let me try to explain you. So firstly we'll be using MNIST dataset in this video. तो MNIST is a dataset जिसके अंदर you have handwritten images of numbers 0, 1, 2, 3, 4, 5, 6. So each image in this dataset will belong to one of the number, right? 3 will, so this belongs to number 3, so label for this would be 3 and so on. Okay. So you see it's a grayscale image, so only there is no red, green, blue, only black and white, right? So this is a data. Now if we look at an image, so an image is basically made of pixels which has height and width. So if I let's say take some image from this photo, so that image basically is just list of pixels from 1,1 to 28,28. MNIST dataset में everything is 28 by 28 size का, right? Now this is just list of pixels, and if I were to train some normal model, for example let's say linear regression or logistic regression or some other simple model, those models only look at an image through at single element at a time. So it will look at this element, then it will look at say this data point, then this data point, and so on. Lekin we do not want that. How CNN works is it looks at data through a concept of filters. Okay. So by filter what I mean is, let's say for our convolutional layer or our network, how we define it basically is something like this. So we do we just PyTorch say from torch dot let's say CNN, we give it input output that is different, but there is one parameter called kernel size. Let's say I give the kernel size of 16. अब 16 से इसका मतलब क्या होगा कि take 16 by 16 का I'll use 4 seems fine. तो इससे इसका मतलब क्या होगा कि 4 by 4 साइज़ का इसमें एक स्टार्ट फ्रॉम 4 by 4 साइज है, ठीक है. दिस इज़ द फर्स्ट कर्नल, ठीक है. और सो आई मेंशन इट्स 4, आई डोंट नो, या. एंड देन जब वो फर्स्ट टाइम लर्न कर रहा होगा तो इन सारे डेटा पॉइंट्स पे लर्न करेगा, ठीक है. सो इट इज़ नॉट 1 by 1 मैपिंग, लेकिन CNN के अंदर इट टेक्स ग्रुप ऑफ 4 by 4 एंड देन लर्न ऑन दिस मैट्रिक्स अबाउट द फीचर्स जो इस मैट्रिक्स में है. एंड वंस दिस इज़ डन, once it has learned this, then this move to the next 4 by 4 and it will slide through the entire image like this. It will slide through the entire image, and this is our first feature. So our hope is that this kernel with 4 size learn something unique about this photo, ठीक है. इस साइज के कर्नल के अपना वेट्स एंड बायसेस होगा. This will has its own weights and biases. मतलब इसमें 4 by 4 का है तो 16 एलिमेंट्स हो गए, एंड देन 16 एलिमेंट्स न्यूरॉन्स के अपने वेट्स एंड बायसेस हो गए. एंड द गोल इज दैट इट लर्न समथिंग अबाउट दिस इमेज, एंड वी कैन हैव मल्टीपल फीचर्स, मल्टीपल ऑफ दिस कर्नल. सो लेट्स से आई हैव for the sake of this video, I'll be referencing this ChatGPT conversation of mine, because I have done extensive research here. तो तो इसका एक और पैरामीटर होता है कि when you initiate it, so these are the parameters that you use to initiate it. So we'll just use the same thing, ठीक है. So we say create a 2D convolutional layer first is the number of uh, number of elements in each pixel. So MNIST dataset, like I mentioned, is only having black, like it's a single channel dataset. तो अगर वी वुड हैव समथिंग एल्स, यूज समथिंग एल्स, फॉर एग्जांपल सम रियल इमेजेस वगैरह, तो उसमें RGB होता है, रेड ग्रीन ब्लू. तो यहाँ पे 3 होता कि दैट इज़ द नंबर ऑफ पिक्सल्स इन, दैट इज़ द नंबर ऑफ चैनल्स इन दैट in normal images. But this MNIST only has one, which is gray, that's why it's only black and white, right? So this is the first कि एक convolutional का कितना element होगा. Then second argument is 6. This is the number of filters you want. तो अभी we created this filter here, right? We created this filter. So this is filter number 1, and we are saying we will have 16 such filters. If I can, so we are saying we will have 16 such filters. 1, 2, 3, and the goal is that her filter maybe would want to learn some unique feature about this image. कि अब जब ये वाला filter इस पूरी image के go through करेगा तो it will learn something about this image. Then there will be, क्योंकि इसके अपने weights and biases है, right? And then there is some next another filter, and वो कुछ और learn करेगा. So all these 16 filters will go through this image, entire image, and try to learn something about it, right? So we got the first is the number of channels, then second is the filters, how many filters we want, then we have kernel size. कि इस केस में this is using 5 kernel size, but we were in this example saying 4. तो it is the number of like the grouping size कि कितना group करना है एक साथ. तो this would be 4x4, and if I use 5 then it would be 5x5 का size, and if I use 28x28 तो पूरा का पूरा image ही एक ही kernel बनेगा बस, right? So that's the kernel size. Then we also have, okay, I think it did not had all the thing meant, not. So then comes stride, okay, and then there is padding, okay. So if you see this, तो first let's cover what is padding. तो padding का simple है कि if you see this, if the size of this kernel is 5, and if I just start, why I'm not able to copy this, I want to move this shit. So if I start from here, this is size 4, so let's make it size 5. So if this is the size 5, okay, so if you see, I'll be training it here, then here 1, 2, 3, 4, 5, 6, and end में जाते जाते if I just move, when I reach here, तो last के some pixels will be like you see कि 5 pixels would be left, right? यहाँ से if I start, then I train this, and last का there would be pixels left, जिसकी वजह से we need some padding कि वो pixels भी get learned. So that is this padding parameter, and I'll show you some description about it in this chat. But yeah, that is the padding, and we'll see this. Stride is simple. Let me check stride again, because yeah, so stride is equal to 2 means move 2 steps at a time. तो अगर stride 1 है तो इसका मतलब है कि if I'm here, the next step would be here. If stride 2 है, then that means कि अगर I started here, the next step would be 2 step forward, right? So that's what stride is. Padding I have explained, and now let's try to see the code की कैसा look करता है. So I'll be copying some of the code here. So yeah, so we import all the required libraries, and we also import the data. just get the data from previous minutes. Yeah. So this is loading of our data. We have training data set and then test data set. So, and then we are converting this training data set into batches of 20. So this each value here, if you see here, training data set, there is 60,000 images in this data. Okay. And if I just look at 0th, then it's basically a tuple जहाँ पे 0 is image, this is image, and train data set का 0 is label. That's how this data is arranged. So every point पे there is image and label in a tuple. Okay. So, and then what we do is if you think about this now, then train data set ka 0, which is an image. So this is an image number 0, then we have image number 1, and so on, image number 2, and iska shape would be 28, 21, 28, 28. So this is the number RGB ka, so iske andar this is grayscale, it's only 1, so RGB is not required, there is only black and white. Then there is 28, 28, which is the height and width of this image, right? And then if I do the label for this, if I want to print the label for this, that should be in first. So that belongs to label 4, so it means कि ये जो image 2 है, it's number 3, right? So yep. So now data loader, what it does is like I mentioned in previous image videos, so it takes the entire data and split it into test and training data set. So it batches the data randomly. 60,000 में से it will take random indexes and batch them into size of 20. ठीक है. So currently जो हमारा data set था वो अब batches में convert हो गया होगा. तो if you see this thing, इसका shape, which I wonder should be printing, or okay, it does not have shape, but so basically ये एक batches में convert कर चुका है इस images को. तो now there would be batches of, let's say 20 we have mentioned, तो 1 से लेके 20 तक there will be images, then there should 21 से लेके 30 तक there would be images, and so on, right? So ऐसे batches में it has translated the data. If I were to just print some of it, I can just loop over it for I comma images comma labels in train loader print. Okay, I have to enumerate here. Print. Let's just print the first image. Break. Print. So since images are like I said in batches, so ये would be like either we have 20 images. We will have 20 images. Let's print, right? So if you see now, so images ka shape is 20, 1, 28. 20 is like randomly it chose 20 images from that entire data set, and this data loader converted that data into batches. So there are 20 images, 1, 2, 3, 4 till 20. Okay. Each one of them is of size 1, 28, 28. Okay. तो फर्स्ट इंडेक्स पे देर इज एन इमेज जिसका साइज ये है, देन सेकेंड इमेज पे सेम चीज, एंड सो ऑन. ठीक है. नाउ ऑल्सो दीज आर रैंडमली चोजन इंडेक्सेस. ये 1, 2, 3, 4, 5, 6 मैंने जो इस इमेजेस के अंदर है, दिस डेटा लोडर शफल्स एवरीथिंग एंड गेट द randomly chosen images. ठीक है. So now we have so we have images, and वी हैव लेबल्स. सो 20 इमेजेस है और उन सब के लेबल्स हैं हमारे पास. ठीक है. अभी हम नेक्स्ट क्या करेंगे इज़ to first we will initiate our convolutional neural layer. Then we will also um, have a normal AI loop, right, जिसके अंदर feed forward होता है, loss calculation होता है, and optimization होता है, right? So we will have that all, and then we will train our entire data set to predict the values or the images, right? So I'll see. Okay, first let me just copy this thing. I'll check layer 2 and layer 2, and yeah, I'll copy only first layer so that we can first understand कि ये कैसे काम करता है. ठीक है. So this is the layer 1 of our model. ठीक है. It's a sequential layer. तो sequential से मतलब कि first this will run, the output will goes to this, then this, then this. Simple. Now let's see how it works. So convolutional neural net, we initiate this layer. Okay, so it will be looking something like this. If I can add another image. Okay. So we have a sequential layer. The first thing that happens is we have convolutional neural layer, CNN. Then iska output goes to batch norm. Then the thing goes to batch norm. And so on, right? So first thing that happens here कि हमारा input is 1, the channel is 1. We have 16 filters कि जो भी image आएगा उस पे 16 filters will be running of size 5x5 on the entire image with stride 1 and padding 2. Right? Padding, like I mentioned, is required to make sure that all the extra pixels are also covered. The extra pixels are covered, yeah. Right. So first this will run. Then we have batch normalization. Batch normalization and that to 2D on 16 filters. This again is a normalization layer कि जो भी weights अभी learn किया है इस model ने, उनको this batch normalization will make sure कि वो जो weights tune होंगे, those are tuned by not going to extremes. तो basically अगर ये convolutional neural net में जितने भी weights है वो कोई extreme values ना ले ले. They do not go into extreme positives or negatives. So this batch normalization, what it does, it makes sure कि हमारे जो weights है वो smooth out हो जाए इसमें. So that's what this normalization does. It's a very good practice to have it so that you do not get unexpected tilts in your images and something like that. तो basically weights को normalize रखता है. Then we have ReLU, which is a activation function, right? And then we have max 2D. ठीक है. तो अब we will see all what all these are. ठीक है. I have covered this chat has covered most of it, so I hope कि we'll know mostly. So yep. So yeah. So first question I asked was कि like how many neurons are there in this layer, right? So like we saw here कि how it works is कि each filter if I can just get, okay, we'll take the upper filter. So each filter जितना भी उसका size है has its own weights and biases, right? तो अगर इस filter का size है 5x5 तो it will have 25 neurons, right? So it will have 25 neurons and each neuron has its weights and biases, right? So and the weights of neurons depend on the input, right? So our input size is 768, so we will have 760. So our input is 1 into 28 into 28, which is like 786 pixel. So this is the input. जो इमेज जाएगी, दिस इज द साइज ऑफ दैट इमेज. So this image will have 786 pixels, and if our convolutional neural layer have 16 filters, so you can just do the math. 16 filters each will have of size 25, so that is like 16 into 5 is something. 16 into 5 is 80, so we have 80 neurons, each have 768 incoming connections, and then there will be some, and each will be learning some feature, and each filter will be learning some feature about that image and giving the output as a whole batch, right? So first so yeah, we were going to that. So yeah, so so I asked this question ki how many neurons are there, and it is like so does layer 1 have 16 neurons? No. You can think of it as 16 groups of neurons arranged in 2D grid, right, like I mentioned. And this also shows ki output of this layer kya hoga, which is like batch size, jitna bhi our case batch size is 20, right? And then there is 16 filters, so since we have 16 filters, so wo, and then there would be 14 cross 14. 14 is coming from this means where is 14 coming from? We have not downsampled it yet, so it should be not 14, but it should be batch comma 16 comma 28 comma 28. That would be the output of after just running it through the first convolutional layer. So iske baad the output would be batch size 16 28. This is correct. Oh, I think AI has given wrong answer, right? Then we do batch normalization. अब ये जितने भी weights थे इस convolutional layer में, यहाँ पे it weights gets normalized ताकि extremes ना ले वो weight. यहाँ पे then we have activation function. अब जितने भी हमारे weights हैं जो activated है उनको it will give the right activations, and the ones that are not given the activation, so that जो gradient है वो properly follow कर पाए. And here what we do is we downsample this image. We downsample it so that we only keep the important aspects of that image. तो इसमें क्या होता है कि we have this image, right? We have this image. If I just remove this thing, yep. So जो भी अब यहाँ पे क्या होगा कि ये 2x2 साइज का डाउन सैम्पलिंग है, कर्नल साइज 2 स्ट्राइड 2, ठीक है? तो ये क्या करेगा कि इट विल टेक 2x2. इसमें जो भी वैल्यू सबसे ज़्यादा है, लेट्स से यहाँ पे वैल्यू थी 10 4 6 2, तो जो सबसे ज़्यादा वैल्यू है 10, विच इज़ द मोस्ट इम्पॉर्टेंट पिक्सल, देन इन दिस केस ये सिर्फ उसको रखेगा एंड बाकी सारे पिक्सल्स को हटा देगा. सो इट विल कंप्रेस दिस इमेज बाय फैक्टर ऑफ 3. तो 3 पिक्सल्स को हटा देगा, ओनली द मैक्स वैल्यूज विल बी रिमेंड, एंड ये फिर उसके बाद स्ट्राइड इज 2, तो ये देन इट विल गोज टू द नेक्स्ट, लाइक फर्स्ट सेकेंड. अब ये यहाँ पे करेगा सेम चीज़. So it will compress this image to a size of 6 batch size, क्योंकि ये तो batch है, इसको तो हमें छेड़ना ही नहीं है. Then 16, which is correct, कि 16 is the number of kernels, so हर kernel के साथ ही हो रहा होगा. Now जो image है वो 28x28 की बजाय हाफ हो जाएगी, which is 14x14, which is 14x14. So this layer will output this thing. इसका output ये होगा, ठीक है? Now this layer just outputs this, and we can try to अब जब भी हम इसको इमेज देंगे तो ये आउटपुट ये रिटर्न करेगा, ठीक है. Now obviously this is not something we want. We would want कि लास्ट लेयर जोन सी होती है उसमें सॉफ्ट मैक्स हो एंड देन दिस प्रोबेबिलिटी, बट आई विल जस्ट ट्राई टू रन दिस लेयर एंड सी व्हाट हैपेंस. If I just send this layer 1 पे images and I take the out and I print the out dot shape. Yep. So we have 20 which is batch size, 16, 14, 14 which is correct. Right? तो ये now first time it has passed through this entire thing and ये सब हो चुका है. Like it did the convolutional, it took the batch normalization, it did the reloop, and then it compressed it. Right? Now next what we can do is take that output जो भी आया है and we have another layer. I wonder if we need that. Okay, let me take the direct feature. We will go through the last layer directly. Okay, and this is the last layer. What it does, it takes where is this 7 coming from? Okay, we have further downsized it here. So we'll have to do some calculations. This is correct. So we have 10 labels कि इसमें से कोई एक को predict करना, and we have these many inputs. ये जितने भी inputs है इसमें batch size into 16 into 14 into 14. Batch size not required क्योंकि वो it takes care of that internally. तो all these layers का output will go into this linear layer and output will be 10 something in like 10 में से कोई एक, right? Now these 10 output are our logits, so we can't directly work with them. We'll have to softmax them and convert them into some probability distribution, right? So what we can do here now is जो भी हमारा इसका output आ रहा है, firstly let me just show you how do we call this. So output जो है fc को we can call on out and let's print res. Sure. Oh sorry, we have to run this, then this. Okay, out is I think it needs batch size also. So okay, yeah, we have to, since this input is this input is like a linear input, so we have to convert this 2D input which is like 16, 14, 14 into linear. So we just convert it like this, or we can actually just, so basically out को we just stretch it, we stretch this out जितना भी आया है, and we'll send it to this thing, right? And now shape is 20,10. तो batch size and उस हर एक का batch size का we have some response कि भाई पहले वाले का prediction, दूसरे वाले का, and so on, right? Now we do the loss कि भाई इसमें loss कितना है. To calculate loss we need to use softmax and do a backward propagation. So what we do is we create some loss function which is cross entropy should be fine, and optimizer we will use Adam optimizer. We have layer 1 के parameters and last layer के parameters added. These are the complete list of parameters with the learning rate of, since the data set is okay, this should be fine. So we have a loss function and optimizer, ठीक है. We just initialize them. अभी ये जो res आया है, इस res से we need to figure out loss, right? Which is this. तो लॉस इज़ बेसिकली कि जो भी हमारा आउटपुट आया है और लेबल्स क्या थे, कि उस पर आना क्या चाहिए था, राइट। एव यू सी लेबल्स का साइज़ भी यही है, लेबल्स का साइज़, यप, बैच आई आउटपुट साइज एंड लेबल्स का शेप सेम होगा। ओके, सो we have 20 labels and we have 20 outputs, right? So we just run our loss function to calculate the loss. We do the zero grad because when our gradients do get accumulated, we don't want that. We do loss dot backward, perfect. तो इससे क्या होगा, now the teaching starts and all the gradients flow backward and gets all the weights and biases gets their gradient. Then we do optimizer dot step. यहाँ पे now what happens is कि gradient gets added to the weights or subtracted so that loss can decrease, normal thing. And we'll print loss after every 100 iterations. Yeah, that should be enough. Let's try to run it. And yeah, you can see our loss has decreased a lot already. It's still decreasing. Oh, it started to increase. So if I somehow can do control C, ठीक है. So loss currently is very nice, which is 0.31. Now let's run this thing on. This was training. Now let's run our test to figure out our correct loss. And this is the loss that we should be reporting, because now this might be overfitting, but this is the correct thing. So yep. Okay, one mistake we did is we ran this thing without setting the no grades, so gradients will still be flowing and we do not want it to flow, because we do not want it to learn in the back, do not do backward propagation on test data set. But if you see, our loss has significantly been reduced. It's 0.2, which is pretty good loss. And yep, we have now trained this model to work this CNN model.